Hi everyone, so after seeing Coulomb's law, now it's time for application. We have our first application. So 2-point charges QA and QB are placed on the x-axis at points A of coordinate minus A over 2, 0, and B with coordinates A over 2, 0. A positive point charge is placed on the y-axis at point C of coordinate 0 and C. We assume that the three charges are equal, which means that QA equals QB equals QC equals Q. 1, 1. Give the expression of forces FA and FB exerted by the charges located on A and B on the charge located on C. So I have here, if I want the force FA, the force FA is exactly the force due to charge QA on QC and equals, so first we have our constant 1 over 4 pi epsilon 0, because here I have QA and QC, the force due to QA on QC, I have QA times QC over AC squared, the distance between QA and QC. And I have exactly here the unit vector UAC from A to C, because here I have the force due to QA located on A on C. Okay, so the source of this force is QA and the application point is C, so from A to C, where the unit vector itself, UAC, is exactly the vector AC over the magnitude of AC. And the charge, this product, the charge, because the charge QA equals the charge QB equals the charge QC equals Q, that implies QA times QC equals Q squared. Therefore, please, for UAC equals AC, C vector calculus and exactly maths for electricity and magnetism. If you have, for example, a certain vector BC equals BC UBC. If you have AB equals AB, the unit vector UAB, which implies that if I want the unit vector UBC equals the vector BC over BC, etc. So if I want my force FA, which equals QF due to QA on QC, equals Q squared over 4 pi epsilon 0, and I have the vector AC over AC cubed now. And look at here, please. I want to use here Cauchy's relation. I have my vector AC like that. Look at here. My vector AC is exactly equals the vector AO plus the vector OC. Okay? And the vector AC itself equals AO plus OC. And remember that here, the coordinate here, the coordinate of A is minus A over 2, 0. So from this origin to here, this is A over 2. So for AO is exactly A over 2, the unit vector I. And what about OC? Because from the origin to here, to my point C, I have a distance C. Remember here, I have C of coordinates 0, C. Okay? And for OC is exactly C times J, the unit vector J. Here, it's quite simply my Cartesian basis, or standard basis also. And also for AC. What about AC? Remember that if I want AC, because here I have a right triangle, because here I have an angle equals pi over 2, I can use Pythagorean theorem. So here, if I want AC squared is exactly OC squared plus OA squared, which equals C squared plus A squared over 4. So if I want AC is square root of my AC, which equals C squared plus A squared over 4 square root of that. Equals C squared plus A squared over 4 to the power 1 over 2. Therefore, if I want AC cubed equals C squared plus A squared over 4, I just add here to the power 3, here to the power 3, here to the power 3. This 3 goes here. So I have AC cubed equals C squared plus A squared over 4. All that times to the power, all that to the power 3 over 2. Hence my force F due to QA on QC equals Q squared over 4 pi epsilon 0 A over 2I plus CJ over C squared plus A squared over 4 to the power 3 over 2. And it is my expression, the expression. I want exactly this expression here. It's very simple.